All right, hello. Today we'll be talking about first missing positive. Given an assorted integer array nums, return the smallest missing positive integer. You must implement an algorithm that runs in O of n time and uses constant extra space. Yeah, I don't know what else there is to say about the problem. I think it's pretty self-explanatory. Um, yeah. So still using cyclic sort. Um, so the classic uh, while loop. Uh, and so now we we want to do the problem that was like um, just sorting or like finding the first missing number in the questions, like finding the first missing number from like I to n, something like that. So basically want to do the same thing like that. Um, but it's slightly different because obviously we are not guaranteed to have the numbers where we're not guaranteed to always have the first I through n or whatever numbers, and then we're just trying to find a missing one. We could have a huge jumble of random numbers, like let's just say for example this one, and yeah, we just want to find the first missing positive integer, which would be 1 if it's not in the array, and like 2, 3, whatever, moving up, right? So in order to do this, we will have um, variable j that stores whatever number we're currently looking at, right? So looking at this one, we're currently looking at number 1. And so since it could be literally any integer, I guess it will be restricted from negative 2 to the 31st power all the way to 2 to the 31st power minus 1. But like essentially literally any number, right? So we need to have a few bounds. If j is greater than current, if j is greater than the length of our array, wait, no, if it's greater than 0, sorry, I'm trying to mix up two different conditions right now. So j has to be greater than 0 because we're trying to look for the index that it goes into, right? So for 1, since we're looking for the first missing number, we want 1 to be at the first index and sorted upward, just so we can find, whether or not 1 is in the array or not. 2, if 2 is in the array, 3, 4, moving on, right? So right now we want to sort it ideally from 1 through whatever number upward. And obviously in between, there can be random numbers such as negatives, zeros, very large numbers. But as long as we have the condition of nums I is equal to I plus 1, we want to perform swap. I can't type. So basically we're just trying to make sure that we want to make the swap right now, right? So if j is greater than 0, j is the number that we're currently looking at, and j is less than length of nums, just so if it's greater than length of nums, we don't try to swap it because that would be index out of bounds. And nums I does not equal to nums j minus 1. J minus 1. So the way that this works is nums I is the number that we're currently looking at, right? And we want to see if we can slot it into the index that we want it to go in. Because these two conditions first guarantee that it's within our list length. So here, for example, we won't look at 1 because that's not exactly what we want. So here 3, we want it to be an index 2, right? So nums I would be 3 here, and then so j would also equal to 3, right? So j 3 minus 1 is 2, nums 2, 0, 1, 2, because that's where we want to put it, right? So if it's not equal, then we want to perform swap here. Whoops. Perform swap in here, right? So as we have been doing, we want to do nums I. Okay, actually it's not. I need to have the minus 1s in here because that's where we're comparing it on, right? So you want to make sure that it's actually going in there. And maybe you might ask, why don't we just do this, right? To minus 1, because j minus 1, j minus 1, and j minus 1. It's because we have these two conditions here where we look at the variable j value itself. So I guess theoretically speaking, you could compare, you could do what the equal to 0 and like minus 1, right? You could do this and have this minus 1 here. Well, oh my god. Minus 1, and then you can remove these minuses 1s if you really wanted to. But like logically speaking, writing code, you probably want stuff that just makes more sense when you read it. And this does make more sense because we're looking at the number and we're just trying to find the right index for it, right? And so that's how we will perform the swap. And so yeah, that's just the condition as to why we want to perform a swap. We're going to have an else statement where we just increment I. Basically, either we can't swap it for bound reasons, or we just already have the number there, or it, you know, is, yeah, or we already have it there, so there's no point in swapping it around, right? And so for I in maybe I shouldn't use I again. For index in range of length of nums, if nums I does not equal to I plus 1, we want to return I plus 1. And then at the very end, if we don't return anything in this thing right here, we want to return length of nums plus 1. Looks right to me. And so if we were to submit it, we will see that we are actually wrong. Index is out of range. Oh, not I. Whoops. Index. Yeah. The downfall of using I as your iterator number thing, and then you try to use it here again. Unfortunate. Yeah, so there we go. We actually do get accepted. Slight debate. But anyways, yeah. And that's how I would do first missing positive. Thanks for watching.